Static sites are easier to deploy, simplifying hosting and making it cheaper as well. For example, GitHub lets you host a static site for free. If the site is static, this also means there is no backend, but there is still a lot you can do just with GitHub Actions, as you are given unlimited usage minutes for public repos running an Ubuntu instance with 4 cores, 16 gigs of RAM and 14 gigs of disk space. Not shabby at all, right? In this video, you'll learn how to deploy a Hugo website into GitHub, the best way to trigger compilation and deployment, which is what makes scheduling possible, and how to use Hugo's built-in RSS feed and a simple Python script to automate social media posting. All of this without spending a dime. Let's go! So first you need to go into GitHub and create a repo with your username .github.io. This is where pages will live by default for your user, and you can access the website that you deploy here via this domain name as well. By default, your website will live in the root of this repo and in main branch, and should be already precompiled. However, if you are using a tool like Hugo to generate your pages, you can deploy into a separate branch instead. We usually use G8 pages for this, and you can pick whether you deploy from root or from /docs as well, which might be useful as a different setup in main, for instance, in the main branch. You can also set a custom domain, and it is recommended that you enforce HTTPS as well, since GitHub supports this out of the box. In order for you to set up a custom domain, if you've got a DNS that you can edit, you need to point your A record into these IPs, which are GitHub IPs. You can also do this for IPv6 if you're using IPv6, and it is also recommended that you set a CNAME that points to your main host name. It's a static file, a file that you are serving, like this CNAME, and this CNAME should contain your custom host name. This means that it will change from, for instance, datalabtechtv.github.io to datalabtechtv.com, which is how we, deploy our website. So now let me just show you how you can compile your Hugo website, and for this we are using a makefile just for convenience. And so at the root of our main branch we've got this makefile, and this is the default build. We just run Hugo minify to save a few bytes, while we are working on a post or preparing some UI change or something like that. We usually run Hugo server -df on the localhost. We just use this -b with the specific localhost name, so that when you run this on the terminal it will show the full URL with HTTP, and it's just clickable. It's quicker to do it that way. Other than that, you wouldn't need this because it runs by default on port 1313 anyway. And so these flags, DNF, they stand for, D is for draft and F is for future, and this F flag is what lets us schedule posts. If you include the D flag, this means that you are also compiling draft posts. So when you are working on a post, you usually mark it as a draft in the front matter, and let me just show you an example of this. So for Hugo, the posts live under content, and for instance I've got the Postgres maximalism post over here for my index.md, and let's look at the raw file instead. As you can see, there is the draft set to false over here, but when I started working on this post it was set to true. and if I didn't use that custom flag on the makefile, I wouldn't be able to see this post, you know. So if I didn't use D over here, I wouldn't see that post, that wouldn't be compiled or displayed. The same happens for -F, and -F only renders posts that have a date in the future. By default, they won't be compiled, and this is what enables us to schedule posts with Hugo, because you just need to recompile it close to the date, or right after the date when you want your post to go online, and it will pick up the future posts that hadn't been picked up by default, you know, because just the date is now in the past. And this is the strategy we use here for scheduling. So for the deployment, there are many strategies. You can, for instance, just git ignore your public directory, and then you need a repo over there, and that repo is just your main branch on your GitHub pages. Or you can simply deploy into a separate branch, which is what we do here. And the way we do it is we just reproduce what GitHub Actions do. So if you ever need to manually deploy some change, we can do it without needing to trigger the GitHub action, although we could trigger it manually as well, just for convenience. So essentially what we do is we build the site, we cd into public, and we remove any git repo that might be initialized over there. We initialize a new repo on the main branch. We configure our private key for this particular repo, and we configure the username and email to make sure it matches the same username and email that we are using for our regular commits. And doing it this way will distinguish between you know, using an action or doing it manually. Then we add all files, we just do a commit with all compiled files, and we add the remote to point to this to our existing repo, and we force push our main branch into GH pages. So our main branch is under public, not our main branch containing the code, and then so the site is compiled over there, and then we just push this force push into pages. This will overwrite or redeploy our site essentially. Once we do that, the GitHub will automatically trigger a GitHub action that does the actual website deployment, you know, from that code. So now let's look at the actual actions for scheduling. So this is the default GitHub workflow, and so your actions are kind of reusable modules that you can combine into a specific workflow. Each action contains one or multiple jobs, and each job has a bunch of steps. These steps can, you know, mention other actions that are publicly available that just run, you know, tasks that are extremely common and makes your work easier. So this pages build and deployment action is the default one by GitHub, and this is what takes your, you know, configured compiled website and actually deploys it into, you know, maybe Nginx and the corresponding virtual host or something like that. And we also created a separate action called Hugo Rebuild Weekly, and this is a scheduled action. It runs on Tuesdays after the YouTube video goes up. For our case, this is what we were interested in doing. So when you look at the log for an action, you get to see the action setup. So all the dependencies, external actions are downloaded. Then your GitHub repo is checked out, and this is a specific action that we are using here because we need our code in order to compile it. We need it inside the Ubuntu runner, which is the VM that's running the GitHub workflow. Then we use an action to set up Hugo, which, like I said, these are modules that already exist and make your life easier. And then finally we build our website using just running Hugo, because Hugo will now be available within your runner. You can just run Hugo minify and this will recompile your page. And then we just deploy using this actions GH pages, which is an action built specifically for making GitHub page deployment easier. And finally, it just resets the repo for the next job to make sure there is no credentials or anything sensitive leaked, since runners are, you know, reused among multiple users on the same repo. Now let's look at how we can set up such a GitHub workflow. So we create a .github directory with a workflow subdirectory on the root of our repo, and then we create a YAML file. For instance, this one is called deploy because it will, you know, recompile and redeploy the Hugo website. And so it pretty much has a name. This one is called Hugo Rebuild Weekly. This name is the one that will show over here. So on your, you know, if you go into actions, you'll see it over here. If you click this, you'll be looking at the logs for your GitHub workflow. If you click a specific one, you'll be able to see the jobs for this one. We only have one. You'll be able to see the workflow as well, and if you click a job, you'll be able to see the details. So this particular workflow runs on a schedule, and this is every Tuesday at 11:15 UTC. This is 15 minutes after the YouTube video is released. So the post is scheduled for 11 AM UTC, and after 11 AM the post is no longer a future post and it will be compiled by Hugo. And we also include this workflow dispatch, which just lets us trigger this manually if we want to. Then we have our jobs, and we only have one job called build deploy. This job will run only if the branch we are running from is GH pages. This is redundant. This is only used if we are triggering it manually. It is redundant for scheduled GitHub workflows, because the scheduling only works on the default branch, which is usually main. Either way, if this condition is true, then we will move forward. This will be running on the Ubuntu latest runner, and then these are, you know, this is an array of steps. This uses is the way that you have to import an external action. These are available on GitHub. There is a repository containing all these actions. And we are using checkouts, and we are including submodules, because for Hugo we are including the theme as a submodule. Then we are using this action by Piece Iris, which helps us set up Hugo. These are, you know, the arguments for the action, so you can specify a version for Hugo, and our website wouldn't compile for this specific theme, which is Blowfish, unless we used an older version of Hugo. So we are using this specific one, and we are using the extended as well, because this option was required for us to be able to convert our images, I believe optimize the images for the web. Then we just create a simple action that does not import any external modules, and it just runs Hugo minify in order to compile. And then we run a deployment action. Now that our website is compiled, we just use this Piece Iris actions GH pages to deploy our compiled website into the GH pages branch on our repo, we need to give it the GitHub token, and also don't forget that you need to give read-write permissions to your GitHub Actions as well on your repo. And then we publish this public dir, so this takes care of deploying our website. Once the code is updated on the branch, then GitHub will take over with the default action pages build and deployment. This will automatically deploy your page after a while. Let's just take a look at a specific action, for instance this GH pages one, to see how this works. So if you want to create your own actions, so there is this file called action.yaml, and this is where you specify that this code is a GitHub action, a reusable GitHub action. There's a bunch of fields over here, inputs for your action, the parameters that you will then set with width, and the main entry point is this one. So in this particular case they are using Node.js, and their entry point is lib index.js, which really means that it's this compiled file which just calls main run. Okay, we go into main, there will be a run function over here, and this function will import stuff like show inputs or get inputs in order to get the configured inputs by the user of the action. And this just uses a library called actions core that has a bunch of methods to access all this stuff, and so it's fairly easy. We haven't converted this into a reusable action, but we might in the future, and it's, as you can see, it's fairly easy to do so. And so now let's get into how to automate your socials after you have deployed your website automatically. Let's say that you had a scheduled post, the post just went up, and you want to share it automatically into your socials just to let your users know that there is a new post they can read. And so you can usually do this via tools like IFTTT, and these have free plans. You can create 2 applets, and it is a bit limited. Some of the actions they provide are not free. You can also use stuff like Zapier, and Zapier also has a free tier, and you have unlimited zaps, but some of these zaps have limitations as well. You have to pay for them. And you also have N8N, which I don't know that well, but this is fully paid. There is no free tier over here. So if you like, instead of using this, and you are a dev that is minimally knowledgeable, you can simply use GitHub Actions again to set this up. And this is what I did with this RSS to social, and feel free to fork this and use it. It's open source as usual. And so let's look into the workflow that I created, which is post from RSS. And so this is based on a particular detail from Hugo, which is your Hugo posts. You go into your Hugo website /post/index.xml. You will find a feed with your latest posts. Okay, so once your website is up, let's say that we had a scheduled post and it went up at about 11:15 a.m. as we had scheduled, and let's say that at 11:30 we'll go and read this RSS and post this information into social media. So we take advantage of this specific URL, and let's look into the workflow itself. So it's called post from RSS, and it takes it stores the last run date on a last runs JSON file that we just commit directly into the repo. So if we go into the root of our RSS social, you'll find this file is committed already, and it just contains the URL for the feed and a timestamp for when last this feed was read. And again, we just schedule this for 11:30 a.m. and we can also manually trigger this action, and we give it force latest input, so that if for some reason something goes wrong and we need to re-trigger it and want to ignore the date from last runs, we can just use a number different than 0 to make sure that the last n posts, for instance, if we use 2, and the 2 most recent posts will be republished. You might need to delete a post, for instance, and change something, and then post it again. And in order for us to not need to delete this every time, we just force it manually. And by the way, let me just show it to you, so how you could trigger this manually. So if you're going to post from RSS, you'll see this button over here, run workflow, and you can select the branch where this will run. And if you want to set a different force latest, you can over here and just click run, and it will trigger something like this. And so we also run our job on Ubuntu latest as well. Our steps consist of checking out the repo, similar as the previous step. Now we need UV and Python to be set up, so we use the official Astral sh UV setup action. Then we run UV sync. This creates the virtual env and installs all the dependencies into it. And finally we run our custom script. It's got a bunch of environment variables that we use for configuration, and I'll get into that. So we run uv run rss to social.py, which is our script. It's at the root of our GitHub repo, and this makes sure that it will be run by UV and using the existing virtual environment. And all these environment variables are loaded inside the script. As you can see, we are also setting a force latest variable over here that takes the GitHub input and sets it as an environment variable, just to avoid added complexity over here with command line arguments. And then our variables are either vars, which are defined on GitHub directly via the GUI, or secrets, which are ways to store securely your passwords, access keys, or secret keys, or whatever. So these will be set up over here under settings for your repo. You'll have a secrets and variables and an actions item, and then we don't use the environment secrets. We just create a new repository secret for secrets. We create the name of the variable, so this looks something like this. Just give it a name and drop the content of the variable. And we also have over here variables that are readable, and one of these variables is our active social. So our script will support Blue Sky, Reddit, and Discord. These look like they are inline, but this is actually a multi-line string, just because we are setting up these environment variables over here via the GUI, so why not. And so what we do next after running this, so by running this, the last runs path will get updated on the runner directly, and then we just commit that path into the repo. So we set up the username and email as GitHub Actions, just so that we know that we are running from a GitHub action. And then we add this file and we check whether there were changes, and if there were changes, then we commit this file. And finally we just push the changes into our own repo, right? And that's it. Next time we run it, you'll have the last run date, and we can just fetch the RSS items that need to be posted to the socials based on this date. So what happens is something like this. So our Python script, before getting into the code, it gets the last runs date, whether or not it should force and the most recent post we posted, regardless of the last run date. It gets a list of feed URLs and of active socials. Then for each feed we determine which entries are new based on these, these parameters. Then for each entry, just create a post for Blue Sky, Reddit and Discord, depending on, if they are active or not. We might just want to, temporarily post to Blue Sky and Discord, and we can just go into the actions variables and disable Reddit. So we will just delete Reddit from here, and that's pretty much it. So now let's just take a look at the Python code for this. If we go into RSS socials, you will find the script over here, and we are using the Pro library to help us post into Reddit, the AT Proto library to help us post into Blue Sky, and we are using requests directly to post into Discord, just because it's a pretty basic request. We also set up a user agent, so it's clear that we are posting from a GitHub action. There's a bunch of logic that isn't really that relevant, but perhaps the most relevant methods are these. So this is code on how to post to Blue Sky. This is using the AT Proto. Then you got code on how to post to Reddit, and as you can see, we are reading the environment variables over here. They are not set, this will output an error immediately. And then we just post to Discord, which is something as simple as sending a JSON file with the content key, and then our post that we build over here. Hopefully this was useful to you. If you prefer reading, there's also a blog post at datalabtechtv.com with everything that we talked about today, and as usual, the code we showed here is open source and available at our GitHub. If you like this kind of content, don't forget to leave a like, I really appreciate it, and you can comment down below if you have any questions or suggestions, or just to let me know that this helped you out. If there's a topic you think you'd be interested in watching a video about, also tell me about it below and I'll consider covering it. Don't forget that you can follow our socials down in the description, or join our Discord server to discuss topics like DevOps, MLOps, data engineering, data science, or anything computer science really. And also because I spent my life at the university for nearly 18 years, I also just created an academia channel where you can go to share your experience and knowledge, or just ask questions if you are either a student, a lecturer, a researcher, or you're just curious about how anything at academia works really. Next time we'll do some graph data science on top of CuzoDB. If you haven't watched it yet, there's already a video about using DuckDB, DuckLake and dbt to create your own personal data lake house, where we run ETL to prepare node and edge data to be imported into Kuzo. It's live right now, so go check it out. And until next time, make sure you keep building your data skills.